Welcome to Erin channel and welcome back to screw thread modeling tutorial videos. So at the moment we've got two completed parts. We've got the bolt and we've got the nut. And if we open up both of these parts in Solidworks, we can press Ctrl and Tab to switch between our open documents. We are going to add both of these parts to an assembly. And making an assembly is just a really good way to check that our parts fit together properly and that there's no problems with them overlapping each other or being too small or too large. So we'll use Ctrl Tab to go back to the bolt part. So before we do all of those things, first we have to change the pitch to 10. And then from the file menu, just select Make Assembly from Part. And this should open up a blank assembly. And we can see that we have both of the open documents, the bolt and the nut here on the left. So select the bolt and just go up to the top and press the green tick. And this will insert the bolt into our assembly fixed to the origin. So next we need to insert the nut, and to do this, go to the Assembly tab. Click on Insert Components. Then just select the nut, and this time don't press the green tick, just move the cursor into the graphics area. And we'll see that the nut should follow us around. And just left click anywhere in the graphics area to place the nut. And at this point we can just save our assembly by pressing Ctrl S or clicking on the save icon. Now we need to mate these parts together, and we can do this using a concentric mate on two of the circular faces. So firstly let's select one on the inside of the nut itself. So make sure we select this flat vertical face and not the helix itself. And then hold down Ctrl and select a corresponding circular face from the bolt. So that will be the actual shaft of the bolt itself. Then a small menu will pop up and we should just be able to click on concentric, and this will mate the two parts together. If the buttons don't pop up for any reason, we can also select the Mate tool, which is on the Assembly tab. And when we open the Mate tool, it should automatically go to a concentric mate, because we've got two circular faces selected. So add that concentric mate by clicking OK. And the two parts should now be mated together along the axis of the bolt. So we should be able to drag nut up and down along the axis. So we are going to check these two parts fit together okay, and there's no overlaps or any problems like that. And the easiest way to do this is to go to a cross-section view. So click the cross-section button, and we should now see a slice through the middle of our model. We may have to click on one of the pre-selections on the left. So either click on the front plane or the right plane, and that should cut directly through the middle of the bolt axis. Now we can take a bit of a closer look at the interaction between the nut and the bolt part. So we want to go to a straight-on view. So from the orientation view menu, just choose a flat-on view. This should be the front, right, or the back plane, depending on how we sectioned our model. And if we haven't got this little view menu, just press the spacebar to open it. Now if we look at the cross-section of our model, we can see we've got a bit of an overlap between the nut and the bolt parts. So we need to drag the nut into the correct position. So just select the nut and drag it down. And as we do, we might find that it rotates and we sort of lose our cross-section view. And if this happens, let's just add a parallel mate to stop the nut rotating. To do this, just select one of the flat outer faces, hold down the Ctrl key, and then also select one of the flat outer faces of the bolt head. And then from the menu that pops up, just select a parallel mate. And we can also access this using the Mate tool on the Assembly tab. Now we might see, like on my model, that the cross-section views are now out of alignment. And we can fix this very easily just by rebuilding our model by clicking on this traffic light icon up here. Or we can press Ctrl and B. So now if we go to our front or back view again, we can see the slice through the model. And if we drag the nut to a certain position, we should be able to see that it lines up, so it's clear of the bolt all the way around. So now we close our cross-section view by pressing the cross-section button again. And we rotate our model around. We can see that the parts actually do fit together, and there's no interference anywhere. We can also see this a bit more clearly by clicking on the nut part, and then from the menu that pops up, clicking on Change Transparency. And this will make our nut part semi-transparent. Now this might be a little bit difficult to see, but we should be able to see that the two threads actually correspond together. So it looks like these parts will work correctly. We can also double check this by going to the Evaluate tab and pressing Interference Detection. Then if we click Calculate, we should be able to see that there are no interferences within our model. This means that no parts are overlapping. And to demonstrate what a problem would look like, if we were to close this tool and then move the nut out of place slightly, and then rerun the interference detection, we should now be able to see that we've got interferences between the nut and the bolt part. So this is just a good way of checking that our parts fit together before we print them or manufacture them. So now we'll just talk very briefly about tolerances. So click on the nut part again and press Change Transparency. And this should make it solid. And then go to a cross-section view again. And go to a flat-on view. And we can see we've got a clearance all the way around between the nut and the bolt. And we can actually measure this using the Measure tool. It can also be found on the Evaluate tab. Just click on the Measure tool. And then click on two lines or 2 points. And it should show us the distance between them. So we can see here that we've got 0.5 mm clearance. So if this area is 0.5 mm, then we can see that it's obviously larger than 0.5 mm between the actual thread profiles themselves. So when we are printing our parts, depending on the exact quality of our printer, I'd recommend leaving at least 0.5 mm of clearance. Maybe if our printing FDM or we have a bit of a lower quality printer, then maybe up that to about 1 mm or 3/4 mm. But the beauty of 3D printing is that we can print it, and if it's either too tight or too loose, we can just print another one, because it's a relatively quick process. And then we can close the Measure tool. So we mentioned in one of the previous videos that this thread looks a bit strange and not quite standard thread. In the next video, we'll look at modeling a standard thread and how we can use thread tables, things like that, to make any sized thread we want. But before we do that, to just finish off this video, we are going to have a closer look at this thread. And we are going to talk briefly about left hand and right hand threads. Close the section view and then go to the front view or back view. And if we look directly at the bolt, we can see that the curve of the helix actually goes up and to the left. And that means that this is a left hand thread. And what that actually means is, to screw the nut onto it, to tighten it, we'll have to turn it counterclockwise. And this is actually opposite to how most bolts work. Most bolts, standard bolts, are a right-hand thread, which means as we turn the nut clockwise, it will tighten onto the bolt. And a lot of people find this quite intuitive. They just know naturally which way to turn to tighten. There are also little memory aids if we can't quite remember. Things like righty-tighty, lefty-loosey we might have heard. So if we are wanting to produce just a standard thread, it should ideally be a right-hand thread, not left-hand thread. Otherwise we might get people accidentally loosening our parts instead of tightening them. Now there are applications where a left-hand thread is useful, and we'll talk about that very briefly in a moment. But to swap the thread direction is pretty easy. All we need to do is open the part by just clicking on it and pressing Open Part. And find the thread feature, the feature 3, and expand it by clicking the plus symbol next to it. Then we just need to edit the helix feature. So if we click on it and press Edit Feature, and all we need to do is change the thread direction from clockwise to counterclockwise, and press OK. Then our feature should automatically rebuild, and everything looks pretty similar, but the thread is now going in the opposite direction. So the helix is now actually going up to the right. Now if we use Ctrl Tab to go back to our assembly, and we go to cross-section view, we can see that again. We can drag the nut into a position where it looks like there's clearance. If we then actually exit the cross-section view, click on the nut, and again make it semi-transparent, we might be able to see that there's now a clash between the threads. And if we run our interference detection again, we should come up with a lot of interferences. So these parts actually wouldn't screw together in real life. That's because the bolt is a right-hand thread, but the nut is still a left-hand thread. So what we'd have to do is open the nut part by clicking on it, and then pressing Open Part, and then expand the thread cut feature, and then edit the helix in this feature, and then just change the direction of the thread from counterclockwise to clockwise. Press OK, and this should update our thread direction. Now if we Ctrl Tab back to the assembly, we can see that the threads now line up correctly. So it may just be worth keeping in mind if we want a right-hand thread, our helix direction should be a counterclockwise for the bolt and also counterclockwise for the nut. As we mentioned in the last video, sometimes these directions can be confusing. So the best thing to do is just look at the part from a front view, and for a right-hand thread, bolt thread should be going up and to the right. Then just check that the nut fits it correctly in the assembly. And if it doesn't, just flip the direction in the nut. I'd recommend probably keeping a right-hand thread because that's what most people are used to. But left-hand threads do have certain applications, used on certain car parts, and most notably, they're probably used on bicycle pedals. So one side of our pedals would be a left-hand thread. This means that as we pedal our bike, we are actually tightening the pedal into the crank rather than loosening it. So that's the end of the video. It's always worth putting our parts into an assembly, just to check they fit together properly before we actually make them. In the next video, we are going to be looking at standard thread profiles and how we can make our own thread profile. So thank you for watching, please subscribe if you like, hope it can be a little helpful and useful.